Hi, my name is Leo, and welcome to this fun tutorial on how to create a photorealistic Earth on Cinema 4D. I'll be using Corona Renderer for this, but you should be able to use them in any render engine you're using. The planet we'll be making is from our upcoming short film Syntactic Labyrinths. First of all, I want to touch on the atmosphere. Then we'll have a look at how we actually create the globe itself. And then finally, we're going to have a look at the clouds. Now, I'm leaving the clouds for last because it's very important to make sure that we're able to have a nice looking, clear Earth with a functioning atmosphere. The clouds are basically just set dressing depending on the story you're trying to tell in this scene. So as you can see on this very clear NASA picture, the Earth itself is still very clear. When there are no clouds, you're able to see, especially from this distance, you're able to see quite a lot of detail. I'm not using a texture that's high-res enough in this tutorial to be able to get this amount of detail in there. The color of the atmosphere by the edges is very dominant, and then it fades out as it goes over the surface of the planet. The closer it gets to us, actually the less visible it is. You can barely see an actual color difference. When I was analyzing this, the first thing I thought is that using a Fresnel would be a good way to achieve this result. So if we look into my materials over here, the atmosphere is a Corona volume material. And inside of that volume material, we're going to be trying to replicate what they call Rayleigh scattering. Rayleigh scattering refers to the scattering of light off of the molecules of the air and can be extended to scattering from particles up to about a tenth of the wavelength of the light. So this is quite a good explanation of what Rayleigh scattering actually means. Our atmosphere will absorb most of the red and orange wavelengths of light, and it will scatter most of the blue wavelengths. Luckily for us, in the volume material from Corona, we can kind of dial some of these settings in. Now the color I went for is kind of a mid-orange, mid-red, almost a brownish tone. The distance is relative to the size of the Earth, which we will get back into, and for the texture over here, a blue texture tends to work just fine, but it doesn't do that good of a job. What I decided to do is use a Fresnel, and in there, I'm using this gradient. Now this gradient we have here is based on a photo that I took. This picture over here is at 5 in the morning on a clear summer night. I went outside and I had a long exposure and a very high ISO, and I simply took a picture of the sky when the sun was just rising. In Corona, you're not actually able to import that image under this gradient, but I decided to color pick some of the colors in there and create this smooth transition all the way from black in the center up to the light blue, white halo, and then the darker blue tones, followed by black. Now the directionality, the higher you go, the thicker it will be. The lower you go, the more translucent it will be. This is something you will have to play around with depending on the scene, the angle of your light, and your camera settings. For me, 0.4 works perfectly fine. Right now I'm using 2800. The higher you go, the less defined it will be. The lower you go, at some point it will be completely opaque. Now the next thing to touch on is how to create the actual globe. As a texture for the globe, I wanted to be able to separate the land mass and the water. This website is very nice, visibleearth.nasa.gov. They have a bunch of very high-res images. So this one, 21,000 by 10,000 pixels. It's quite high-res, but when we're exporting to 4K, you will see that it's still not high-res enough, and you would actually have to go in, create a 52K texture or something. This right here is a clear Earth. For Syntactic Labyrinths, in the story, it's actually snowing on most parts of the planet, so I went in Photoshop and created this version. which is just using an alpha of most of the planet and then just repainting it, retexturing it. As you can see in this texture, our land mass and our water are in the same file, and they actually should be reacting quite differently. Let's open the node base for a second. This is what I did to separate the land mass from the water. I created a layered material in Corona, and then for the base material, that's where I input my water material. And then as a material 1 slot, that's where I input the earth. And I used a mask which alphas out the land into mask 1, which basically puts the earth right on top of our new water, essentially just replacing the water. If we go into my land material, for the diffuse texture, we're using the earth texture from Visible Earth. For this example, I'm still using the one where it's green and grassy. Under the glossiness, I'm using a glossiness map, which I created in Photoshop as well. A value that is not too high, because this is just supposed to be the land. Displacement, there's an elevation map that I found. I have a minimum level of 10 and a maximum level of 20 centimeters. And that's everything for the land texture. Now the water is a bit more complicated, because to make water look nice with basically no environment was a bit more complicated than I expected. First of all, under the reflection, a pretty low Fresnel value, pretty low reflection value, and the glossiness, I was playing around with the sliders, but then I ended up using this texture over here. It's basically a glossiness bitmap that cancels out all of the land mass and just gives the water a like 50% to 30% reflection. And that went into a filter, and that one is just giving it a boost in the gamma. That goes into the glossiness. Now we do have a refraction. We have an index of 1.33, which is the value for water. In the displacement, we're copying the exact same displacement as we've been using for the landmass. That will make sure that both textures are exactly the same in shape and size. And then finally, we have the volumetrics turned on. The mode is volumetric scattering. If we were making like an ocean or something and the camera's quite low to the ground, I would recommend using subsurface scattering for that. For the absorption color, quite a bright blue, 212, 82, 67 if you want to get the exact value. The distance over here, again, the lower you go, the thicker it becomes, the bigger you go, basically the more transparent it becomes. Let me see if we can test that out by putting it to 5,000. Well, there you go. So the higher you go, the less visible. So 339 seemed to be working fine for me. Now for the scattering color, I'm using a very dark blue, 214, 82, and 13. And then directionality left it at 0, mixed strength left it at 100. Now when they're put together inside of the earth material, that should give you a very nice separation that looks a bit like this. Now here's a shitty render that will give you a bit of an idea of what it would look like. We're including the atmosphere and we're including the clear earth. The first thing I'm noticing is that the mountains seem to be a bit too tall. Changing that is quite easy. We would just have to go into the land material and lower the displacement height, and go into the water material and replicate that same change. The water itself looks fine to me. It's a bit gray, but some of that will be brought out in compositing. For the clouds, on Visible Earth, I found these pictures over here. Blue marble clouds. There are not that many clouds going on in here. So for Syntactic Labyrinths, I actually went into Photoshop and I photobashed quite a few more clouds in there. In the film, it's supposed to be a stormy day, so there are some hurricane pictures I found on Visible Earth as well. I got them in there, and a few variations of different, more streaky clouds, more puffy clouds. I'm using the same picture to create this alpha over here. It's basically a crunched black and white version of the original, and I finished off by giving it a slight blue tint and lowering the exposure in the highlights, and this is the final version that we're using as a diffuse texture. Now for the last planet I've been making, I've been using 3 different cloud materials that I've layered in increments of about 10 to 20 centimeters. Let's go into the first cloud material. They're all basically the same, just with a few slight variations. We have the bluish texture in the diffuse. Then we have the translucency checked, which for this one I have on 12%, for the other one on 10, and for the final one also on 12. There's no reflection, no refraction, but we do have an opacity because we need to key out all the blackness. For that, we're using the alpha channel inside of the texture. I'm using bump, just a 3% bump with the same picture on there as well. And for the displacement, I'm giving it 5 centimeters. 5 centimeters is the minimum distance between 2 of these cloud layers. So just to make sure we don't start clipping. And then again, volumetrics. The volumetrics for this entire planet is really what sells the trick. As mode, volumetric scattering, color a very, very dark gray, a 6% value, and the rest is zeroed. And then the distance, 4,200. Scattering, almost white, 87% value, and a pretty high directionality. Now, let's go over these settings again. The higher the directionality, the more defined the shape will be of your volume material. And the distance, the lower that goes, the more opaque, the higher it goes, the more translucent. However, we're using quite a dark absorption color, so we can actually bump this up quite a bit. The distance over here, I kept it at 4,200. It's not as big as the planet itself, but again, this depends on your scene. I've changed the directionality value for the 3 different clouds. Now, this material has 85, so a very defined cloud. This one's 75, and the final one 55. The amount of clouds you end up using, again, depend completely on the story you're trying to tell in your scene. For me, I wanted to have many clouds, but let's add 3 layers of clouds for now and see what the result is. As that's rendering, I would like to take the moment to really make clear that all of this is a trial and error process, and if it doesn't work the first time you're trying it, don't worry. Have a look at this. This is our first attempt at creating the planet Earth. The atmosphere color is still the opaque blue color without using the photo reference gradient. The clouds, they just seem to be too low res. Not entirely sure what's going on there, but it's definitely not working. The Earth underneath, there was still no separation between the landmass and the water, which means that basically nowhere in the image you're seeing a different type of reflection. It's just one opaque sphere underneath a pixelated layer of clouds. Here's another nice image that shows a bit of a progression, but it also shows how my scene setup was quite different at the time. At this moment, this 4th material over here, the glowy one, I was trying to use a light material with a Fresnel at that point to create the atmosphere. For some reason, I thought that the atmosphere would emit light instead of simply scattering the light from the sun. That's one of those examples that shows you that if you don't really understand what is going on, you will probably never get the result you're looking for. This 3rd material over here seems to be closer to what we're after, but there is no Fresnel in there. This is even stranger. We have a very tiny Earth all the way in the distance, and then we went to this massive screen-filling close-up. The problem we were having here is that the focal length on which we shot this piece of asset over here is not matching the focal length we had in our 3D scene. When we originally shot this, we were thinking of having a pretty wide field of view so that we will have the Earth quite far away, but we didn't shoot with that wide of a lens. In the second example, on which we tried using the miniature, at least the focal length seems to be matching more this Earth, as well as using the photo textured gradient, and but it wasn't actually using the volume material inside of the clouds. Over here the clouds are still just flat pictures. We ended up changing the angle to our CG model. This version of the Earth is already a much more appealing version to me. The clouds have these elongated streaks, these God rays coming through them. That's because of their translucency. That's also because of their volume material. And the fall off from the clouds into the shadows. As you can see here, you still have some detail. You're not losing everything. And then there is this version. This version is a bit more dystopian, I would say. We have this thick cloud over here. We have a bit of a thicker atmosphere going on here. We see a bit more of the land. It's nice because some colors are popping through. And again, we have the long, elongated God rays as shadows shining through from the clouds, even creating this beautiful patch of shadows over here. Alright, so the first thing I'm seeing is that the water is still quite gray. It's not reflecting as much as the atmosphere as I would want it to. We can change that. Let's make a region render. Alright, there you go. Now that is a more defined blue color. The only thing we're changing to give the water a more blue color is the refraction color in here, and that would adjust everything accordingly. Now it's time to get into the camera settings. Camera settings is one of the most important and probably overlooked aspects of creating a realistic Earth. We don't really know what Earth looks like to the naked eye, but we do know what Earth looks like to the sensors of different cameras, to the focal lengths of different lenses. I'm using a 200mm. One of the main reasons why I'm using a long lens for this is because in the final scene, we're making a simple pan from a locked off camera position. Now, there's no actual parallax going on the Earth, so rendering out a 4640 by 3260 EXR file that's just a still on a long lens will allow me to just composite that into 3D space and then just move it along in After Effects. Focus distance over here is right on the surface. If you have a look, it's right where we're looking. And the camera settings in the Corona camera, ISO of 200, shutter speed of 1/600, f-stop of 4.8, and then we have an exposure control of -12.5, simply because when we get such a massive shape with very bright sunlight and even an extra light to give it like a fill, it tends to get overexposed quite quickly, especially if you're on an f-stop that's so low. Now we have a very, very fast shutter speed with a lower exposure to compensate for that. On top of that, I'm using a 1.5 highlight compression just to make sure we don't get too many peaks. I have a sharpening turned on with the standard settings, and I have the depth of field turned on, and that's everything. The sun, I have the size at 2.6, a bit larger than the standard 1 size. It gives a slightly softer shadow instead of the harsh straight from the box shadow. The intensity 1.7, give it a bit more brightness. And then we have a Corona light that is basically side lighting. It's on top, it has a size of 300 centimeters, it's not the biggest light, and a intensity of 150 with a white color to represent the moon. Now let's do a new render. The beauty of working with photo textures is that you're working with true randomness. All these pictures from the clouds, none of them are repeating. The texture of the planet, there's nothing repeating in there either. And because we're using a realistic gradient in the atmosphere, the way that the light reacts onto the surface should feel natural, or at least it should feel like something we're used to seeing. So the next step is letting this render. I sent it to the render farm, so we should be able to get our frame soon. But now I'm gonna go into After Effects. The version of Earth I'm using right now is a little bit different than the one that we're rendering out right now. The clouds on top are still a bit too thick, in my opinion. The new version will be able to solve that. So as you can see, it's still a trial and error process, even in these final stages, even while making this tutorial. In this final output, what I have is 6 layers of semi-organic grain. I have an adjustment layer with a curves adjustment that takes the shadows a bit further down and basically tips off the exposure on the top, so we don't get that fully bright white exposure on the edges. We have a vibrance control with -11 and a exposure that brings the exposure even further down while bringing the gamma down as well, so we get some more contrast. And then finally, there's a CC toner on top of this using a tritone of a beige, a cyan, moldy color, and finally a very dark purple. This is supposed to replicate the film stock idea that we would be using if we were in space. Then there's another adjustment layer going on with an exposure, a vignette, and a 500 pixel feather. And finally, another one with a vignette that's slightly off center, and there is a camera lens blur of 7 with a feather of 200. Now inside this pre-comp, there's a simple blue haze JPEG. Then we have a 3D camera, an adjustment layer on the Earth surface. Then the Earth, on top of the Earth, I have an exposure of +15, a vibrance of 30 and 20, and a camera lens blur of 1.5, simply to get some of the sharpness from the digital render out of there. Underneath the Earth, we have all the stars. Now, me and Eric have discussed that we didn't want too many stars going on in the background, simply because we are exposing to this big, giant, light reflecting object. So we're keeping the background as dark as possible. I have a black solid in the background with an 8K star map that I masked out a bit, and a second 8K star map, both positioned in 3D space. And then on top of that, there is an adjustment layer with a fractal noise. The fractal noise simply has an evolution expression. Let's see what we have. Time times 250 expression on the evolution, a complexity of 6, a contrast of 530, and a basic fractal noise. It's simply a rough fractal moving around. This, working with the adjustment layer, will give a very nice twinkle onto the stars that feels natural and relatively organic. Now, inside of the Earth comp, we have the Earth that came straight out of Cinema 4D, which is this one over here. I did create a mask that goes right around the edge of our atmosphere with a negative expansion and a 60 pixel feather. I created this layer, which is a mask with a 70 pixel feather in a medium blue color, which I color picked from our true atmosphere. And then on top of that, another medium blue followed by a darker blue, all with different feathers, 70, 150, and 150. Their opacity, the top one 35, second one 21, and final one 20, creating a very interesting translucent glow effect. Then we have this layer over here, which is a glow. It's a copy from the original Earth with a mask over here and an add mode, simply to create a little bit more of a three-dimensional feeling to this globe by giving it a boost in light on this side. Then I have these two layers. They're basically copies of the original with a soft light and a 15% opacity. I had rendered this version of the Earth as well that had many more clouds on this left area. I did not completely like the result of this Earth, especially as you can see everything looks a bit too opaque and patchy. Only on this top left corner is where it's kinda doing the clouds justice. I'm not the biggest fan of the result of this Earth, but I do think we can still use it. So I turned that one into a soft light mode, and then I turned the opacity down to 35. It's a very subtle detail, but basically it just fills out some of the areas up top and gives a bit more depth in the bottom. There are 2 more layers. There's one more glow layer that's going over the atmosphere, right there on the edge. It's a duplicate of the same mask, one being on subtract with a -8 expansion and a feather. And then finally, one more. This one is also using a fractal noise on top of it. Now you should be able to see what it's doing. It has some variation in there, and it's basically just moving a bit. Now with everything together, we have a very strong rim light by the edge of the Earth, a soft fall off for the glow, and a rather gradual transition from the bright spot all the way into pure blackness. If you put that all together, we get this. I hope this tutorial was very helpful for most of you, and I guess we will start making a tutorial on Saturn next. If you prefer another planet, just make sure to leave a comment below. Leave a like. Thank you, subscribe, and I'll talk to you soon.